Well, let's say this, if we were just outside and we were looking, trying to apply what we were just looking at, if I was to come over here and draw a hub, and I stuck a hub out here, what did we say? If we have the elevation of the top of this hub, we shoot it, we know what it is, we would have the ability to calculate the differences, right? We could calculate the difference in the elevation of the top of the hub versus the point that we wanted to lay out. So we would be able to tell somebody it's this far down or this far above. It's a cut below or a fill above the hub. So maybe to kind of walk through, I just wanted a quick little sketch here of talking about a cut or a fill. So if we were tasked to have to lay out, or we're going to work with a foundation crew, let's say, we have to build this sign foundation. When we get to the site, what do we have? We've got this just earth, right? The dashed line would just be where the ground is at. But the concrete foreman wants to know, hey, I need to know where's the bottom of this foundation. What is it? What do I need to dig to? So what's going to happen? Well, we can come out and we can set hubs. We can set a hub on one side of the foundation. We could set it on the other side. We could set two hubs. Probably only need one. So what's the first thing happens? Right? He digs a hole. Right? How deep does the hole need to be? He's going to be looking to us to tell him how far down to dig. So what information would we need to know? Well, we're going to need to know what? We need to know the elevation of this, right? We need to know what the bottom is. So let's just throw some numbers at this just for the heck of it. If we were to say that the elevation of the bottom of the footing is, let's just call it 625.50. Let's just say that. So 625.50. So we know that the concrete, we've got to dig to that elevation. Well, what if before that we went out and we shot elevations? What if we got a benchmark, did our HI, set the instrument up? What if we got an elevation up on here on this hub, and that elevation was 638.24. 638.24 is the hub. 625.50 is where we need to go. So what do we do? I see Manny punching up numbers. So subtract, right? Manny, what'd you get for a difference for that?
12.74.
Say it again.
12.74.
All right, so that's a really deep foundation. That's all right. 12.74 feet. So that's what we came up with.
What kind of sign is this?
That is a deep foundation, right? 1274. Is 1274? That's a cut, not a fill, right? So a cut. So the way that I'll just kind of show you, everybody's going to be a little different in how they would record it. I have always done that. If we were to say that this is a cut and we label it hub to top of foundation, I'm just going to throw that in there real quick. The C or the F with a couple of little slash marks just happens to be, I'm not going to say I invented it, but I saw it a long time ago. I've used it forever. It's a cut of 12.74 to the top of foundation. If anybody, the foundation guy, if the earthwork guy, anybody that's coming up to that location that needs to do something with it, we want to leave them enough information on the lath, right? The lath is where we could put the prescription. We're going to write that down there. That's how we would label it. Now, the reason why Bob is teaching you about using little slash marks is, it might not be obvious, but it would be if something gets messed up. I'm going to erase this real quick. One of the things that I have seen happen that can cause confusion is if somebody was to say, so we know 12.74 is our cut. 12.74. What sometimes happens is people might just like do that, or they might just say, cut that. What can happen is someone might just say, or it's real small, something small. How do I know if it's a cut or a fill? Does the negative sign mean that it's a cut or a fill? This isn't a quiz. This is just us practically going out to that foundation, and if someone just left on the lath minus 0.26, we don't necessarily know what it is. Being descriptive in saying it's a fill of that number, it's a cut of 2.72 feet. You can't miss, right? You can't miss. It's a fill of that, it's a cut of that. If someone said, I need you to fill, and I put a dash in there, fill minus 0.26, what is that? Am I going up, or is it a minus? Is it going down? Trying to be as clear as you can be, and then letting the subcontractors know, whoever you're working with, hey, this is how our surveyors are gonna lay things out. You can't miss. So it's thinking about how you describe it, because everybody is gonna be reading your work. When you put something on a lath, everybody's gonna be reading it. They need to be able to understand it. As the layout crew, you may go out on a Monday, the sub might not show up till a Thursday. You're not gonna be there, you're gonna be on another job. There's nothing worse than a phone call of somebody saying, hey, I'm out in this foundation that you laid out. I don't understand. I don't understand what you laid out. What is this? Okay, well, sorry, I can't be there, but we'll be there in 2 hours because we're on another job. It's trying to build that in so that the communication is correct. Now, the reason I'm saying this at this point of our class is the likelihood of any of us, you guys, actually laying lath in the ground as part of, probably at this point, probably maybe kind of slim, right? You may get into some of this, but understanding how to communicate with your surveyor, understanding how to communicate with the subcontractor, knowing what the subcontractor needs versus what the surveyor can provide. How do you make sure that you are getting those things talking to each other? So part of this process for us in this classroom is learning how the math works, learning how to lay things out, learning how to have to actually do it. But it's also learning how you're going to manage these different companies, because that's what it is. So if you can communicate to people, hey, I did talk to the surveyor. The hubs they laid out are 4-foot offsets, and it's to whatever it is. You have the language already. You're like a pharmacist that understands how to read the prescription, even though you're not prescribing the actual medicine and putting it in the bottle. You know what it means, so you can communicate with people. That's part of what we're doing here. So these are just little nuances, but they're important, because I've seen it where someone puts this little negative sign in here, and now something's off. Nobody's fault. Everybody's doing their job, what they think it is, but miscommunication. It's just what it ends up being. So, all right. So that's my rant. So in this case here, if we have a hub and a bottom, we can do the comps, right? So the same thing could happen up in here. What happens? Let's say this. Let's say this is our hub, and the contractor wants to know what's the top of the foundation. Where do I need to set the frames to be at the top? So let's do the same thing. If I was to say over here, let's just say the top of this hub is 642.28. So that's the hub. Let's say the foundation top is, I'm going to be a little more realistic now, 645.98. That's where we're going to go to. So what's going on between these two? What are we going to tell the contractor? Is it a cut or a fill? Do we know yet? We think it's, what do we think? We see the difference here, 42 versus 45, right? So it's going to be what?
It's above that.
It's above it. So what would that end up? That's not going to be a cut. That would be a what?
Fill.
It's going to be a fill. So let's do the quick math here. 645, 98. 42.28. Say it again, Crystal. 3.70 feet. So in this case here, it's going to be fill 3.70 feet. Top, whatever that is, top sign foundation. I mean, top of foundation. This would actually. How about this? This is actually bottom foundation, right? Sorry. Terrible here. You get the drift, right?
We knew what.
We knew what bottom meant. So it's labeling that up. Top sign foundation 3.7. We now can tell where the top of that is, and we could walk away. Manny, go ahead.
Why wouldn't that be a fill?
Well, let me clean up my mess over here, because I feel graphically challenged. Why would this be a? Manny wants to know, why would this be a fill?
If that hit or that dash line is the ground. I'm
Yes.
assuming,
Uh-huh.
and it's already at that level, why would it be a fill?
Good. Okay, good question. Let's talk through it. Why do we think that we're giving him a fill? What does the fill represent?
Going above.
Fill represents going above, right? Does the ground elevation? How does the ground elevation play into what we're looking at here in this picture? How does it play in? it's where we started, right? It's where the ground started. Will the ground be there when we are building the foundation?
Yeah.
Probably not, right? So we're gonna excavate it. So once we get into this hole, that's gone, right? So now all we're dealing with is an open excavation. We've got a hub, and he's gonna be working on this stem over here. So what's actually happening? We're telling him from this hub level over, it's 642.28 all the way across, but the top of the foundation is at 645. So that fill Manny comes from the difference in those two, 42. We've got to go up to get to 46, 45 something. So that's why that would be a fill. Does that,
Yeah.
you follow that?
That line was throwing me
That's
off.
it, and that's okay. A lot of that is playing into just the visual of how the grades play into this. It's easy to let the existing conditions get with us when we really have to think about where is the hub and where do I have to put something. That's really the mindset to go with it. All right, so conceptually, how do we feel? Cuts, fills, ups, downs? Okay? All right, now it's game time. Now, don't go information overload on me when I drop this on your desk, because there's a lot to take in. We're going to take it step by step. Yep. All right, Crystal just said it. Oh. So let's go through this. Let's just do a quick flip. What did they give us? Take a look at what we have. We got a description, so we've got our work. We got our work tasks are set out for us. The second page looks like what?
So, our field,
Second page is going to be the field notes.
um,
So the surveyors did some work. Third page is what? Third page looks like a cross section. And the fourth sheet looks like what? Plan view, right? Let me open this. All right, so we're soaking all this in right now. So we've got a cross section of a road. It's got a sidewalk, pavement. It's got curb and gutter on both sides, and it looks like it's got a ditch. So I'm kind of looking at the cross section. I thought I had this pulled up, so let me find. Hang on, get this up. I have it. This is terrible. I had this up and I think I closed the file before. Let's do this. Let's go ahead and read through while Bob is searching for it aimlessly. So let's go through week 6 and just read through. So it says what? We're going to lay out a proposed roadway, and we're just laying out hubs and lath at the appropriate offsets for back of curb, sidewalk, ditch line. So let's do it. Let's do some page flipping. Let's go to the plan view, the back sheet. So we have hubs. Here's what we did. Our crew just went out and we put hubs at each of where the letters is at. So all of the letters represents a wood hub. So we went out, we set those out. Now they're all in a straight line. You see there, everyone's in a straight line. So that means not only did we put the hub necessarily with an elevation, but it's in the right line. So we're that good. We have everything in lines. So if we were to look at AH, IP, and Q up on the top, those are all just what we did out in the parking lot. Those would be the hubs for the sidewalk, right? So if you can picture each of those little plus signs and letters is just a hub in a position. So AHI, those represent the hubs for the sidewalk. How about the next set down here? So B, G, J, O, and R. So those would be hubs that would be for the curb. So we set those hubs for the curb. And then same thing, if the C, F, these down here all the way to S will be for that bottom curb line. And then DEL, this bottom, very bottom set, those will be for a ditch. Because let's go back to our typical section. What's the typical section got? We've got a sidewalk, we've got the curb, and we've got a ditch. So does everybody kind of see the picture? Plan versus cross section? Is it? And if you don't see it, holler right now. Holler right now, because having this is going to be what we need to be able to visualize as to what everything represents in the sketch. So we okay? Think we got it? Okay, so let's go back to the description. It says you've used a baseline and 100-foot tape, and we've laid all the hubs. So we did that. We used an automatic level. We ran a level loop through the hubs, and we've got benchmarks. So let's go to the field notes. Let's go to that second sheet. So the second sheet is kind of what you did last week in the hallways, but just on site. Started with a benchmark, set the instrument up, I got a backsite, and what? This crew went through and shot all the hubs, A, B, C, D, all the way to L. So in one setup, they shot all of the hubs. Out here in the right column, they told us, what is it? What did they lay out? So let's look at the descriptions on some of these. Well, we know that the benchmark is what? It's a railroad spike, it's in a power pole, it's on the northeast corner of JJC Avenue and State Street. So here, as we're doing our homework, as you're doing your field book entries, having descriptions like this, any of us could leave this office right now, go out and find out that benchmark, right? They left a good description, so we can find that. So we know where it's at, so just good repetitions for our notes. So what did they do next? They labeled what is A, what is B, what is C. So let's kind of read, let's decode this a little bit here. So point B, they're telling us point B is a 4-foot offset. BW, probably back of the walk at station 10. Let's go, you guys can flip sheets, I won't keep flipping. Go over to your plan view and just find hub A. So we'll read again. Hub A is a 4-foot offset to the back of the walk at station 10+0. So does everybody see all those things coming together?
Mm-hmm.
Hub and everything at 10. So what's the next one? So B, I'll just read B out. B is a 4-foot offset to the back of the curb at station 10. Okay, we got that, right? Mm-hmm. Let's look at this real quick. The LT versus the RT. Obviously, we know those are left and right. If you look on the plan view and you look at station 10, just go over here. If you look at station 10, when we talk about stationing, stations are always looking what they say up station. So if I flip the page like this and goes up, 10 foot to 1050 to 11, I'm looking up station. So if I'm looking up station, B is to what? B is to my left. And C is going to be to my right. So if I go back to the survey notes, B is to my left, the curb is to my left, C is to the right. The ditch, how about that? D, which is way out there. D is a 10-foot offset to the center line of the ditch at station 10+00. So you guys see how the descriptions go? It should be intuitive. It should be, because that's how this prescription is written, that we should all be able to look at the notes and understand what they represent. So that's how they went A through L. So they did A through L in one setup. Well, then what happened? What they have to do? TP. What's a TP? Turning point? Turning point. So they couldn't get all the hubs shot in one setup, so they had to pick the level up. So what are we going to end up doing? We're going to be able to use this HI after we calculate it. This would be the shot on the turning point, right? Mm-hmm. So we'll get some elevation. I don't know what that is. We've picked the instrument up. We got a new backside on it, and then what? Then they ran all of these points all the way out. So M through U were shot with a different setup. Everybody got it? Mm-hmm. So if we were to, and this was a term, to reduce the notes. Reducing the notes is when someone just gets outside and gets all the shots, but they don't run the calculations. Come back in the office with your field book. When you're reducing notes, you hear that term. that is taking the information and running all the calcs. So right now, we have the ability to reduce the notes to get all the elevations for all the hubs. We can do that. So we've got all that. So that'll be the first step. We're going to reduce the notes. Let's get all our elevations on our hubs. So what does it say then in the description? It says, using the field notes, break them down, find your hub elevations. Now, use the attached plans to calculate the proposed elevations for your points. All right. So this is pretty easy, right? Reducing field notes. You guys did that in the homework last week. How'd the homework go for everybody last week? Okay?
Yeah.
Just pretty much reducing notes is what you ended up doing last week. And I gave you all the answers to them. I didn't realize I left the postings from last term, but you guys have the benefit of that, so that's fine. All right, so now what we have to do is, what's it say? We got to use the plans to calculate the proposed elevations. Okay, so let's think back to that typical section of looking at the ramp, the west frontage road. We're going to have to do a little sheet flipping back and forth. So we know what the cross section is doing, right? If we could find what the center elevation is of this road, what could we do then? We can do the same thing, right, that we did when we were practicing. We can go 8 feet at 3%. We know the curb is going to have a little jog in it. If we needed to get to the sidewalk, what the ground is sloping at a slope. So what we've got to do is we've got to try to come up with the proposed numbers. So let's go to the plan view. So we are working with a plan and a profile. So anytime we got road work, anytime you're doing any plan and profile, they're working together. So the plan view is, we got a blueprint reading. Plan view is what? That's the top down. Yep, looking at the top. The profile is if we flipped it on its side, right? So the profile is what the road is doing. So what's the road doing? It's going from station 10 to station 12. It's going from high to low, right? And its grade is 3%. Do we have enough information, and what are we going to do with it? So let's do this first. We know the center line of the road. What if we calculated the individual center line elevations, just like we did in that ramp typical section that we had? If we knew what the proposed elevation is at each of these points, so that's like we just looked at our slide. If we find this, we can start working our way outside, right? We can calculate those grades. So how do we do that? All right, well, we do this just like we did before. So how far? Let's take this. How far is it from station 10 to station 10 plus 50? Yep. There's no trick questions here. So yeah. So 50 feet. So if we knew that we went 50 feet, and let's just try to line this up. Oh, here's 1050. We got it down here. 1050. I don't want to zoom in too far because I want to be able to go back and forth. So if this is 1050 and this is 10, we know that every time we go 50 feet, how far down do we go? How far down is this?
3%.
So this is 50 feet and it's 3%. So how would we calculate how far down we go?
50 times
50
0.3.
times 0.03. Does everybody see that? 50 times 0.03. What do you get? 1.5 feet. So it's going to drop 1.50 feet in 50 feet. So what's the proposed elevation of the center line of the road here? 629.45.
627.95.
27.95. Yep. So if we go back up here to the plan view, and let's just label these real quick here. 629.45. We just calculated this one at 627.95. We got our first two. Okay, to get to station 11, how far do we go?
50 feet.
You're gonna see a pattern here, right? We go 50 feet out. How far down? 1.5 feet. So we won't need to display it. So we know from 1050 to 11, let's take another 1.5 feet off of
626.45.
620, 645 maybe? 45. Okay. 1150. Same thing, right?
624.95.
And the last one?
623.45.
45. And we check, right? So if we come down here, the designer gave us the proposed elevation 623.45, so that's good. So we have now calculated our center line of the road. So we got it. So we can start working and branching our way out. Now, everybody grab a blank piece of calc paper. Or if you need, anybody need a blank piece of calc paper? Better yet, find my pad here. Give you a couple. Yep, Brian?
Yes.
Yep. Lee, all right? You good? It's always here. Logan? Good? You got what you need?
This notebook is $10. I seen something like $20.
Let's take a look at our cross section and let's see what we're going to need to calculate. So just kind of like we did in that first ramp section. So what do we know? We know we're going to have this, right? What did they need us to calculate? We're going to lay out the back of the curb, right? Well, what can we calculate? We're going to be able to calculate the edge of pavement. How do we get to the curb? How do we get to the back of the curb? What do we know about the curb? It's a 10-foot offset. Yep. How about this? Is it a 10-foot offset, Manny? It's not, and that's not a trick question either. Let's take a look at our curb detail. How wide is our curb? 19 inches. So I'll tell you what, we're going to do this. Let's make this 18. This is an I-dot shape, an I-dot curb. They make them 19, but for simplicity's sake, we're going to say it's 18 inches. 18 inches is what? 1.50 feet, right? So the width of that curb is 1.5 feet. And it's the same on both sides, right? So 1.5 feet. What is the difference in the elevation from the edge of pavement to the top of the curb?
2 feet.
6 inches? Yeah, I jotted it in here. So to get from the edge of pavement to the top of the curb, it's going to be 6 inches. It's going to be 1/2 foot. 0.50 feet. So then, let's look at the two sides. This ditch on the right side, it says varies. All right, we're gonna have to do some work with that. Let's flip over to this side. We can calculate that. We know that the difference of these two, and I know I'm going kind of quick, is 6 inches to get to the top of the curb. What's going on this way? We're going up 1%, right? Mm-hmm. We don't have to calculate these right now. I'm just kind of conceptualizing the things we're going to have to calculate. If we get the top of the curb and we knew how far this was at 1%, we could figure the sidewalk out, right? Mm-hmm. We could figure that out. So we think we've got, if we know what this center line is, we can work our way out. We can calculate anything along that road. Does everybody see that? Calculating proposed grades? So here's what we're going to do with that calc page. Build yourself a little table. And I'm going to give you I'm going to reveal this only because I have the numbers cranked out already, but set yourself up a table that looks like that. And I'm going to slide this over. I sure can, certainly. Once you get those numbers in, then we'll talk through them. So while you're writing, the beauty of a lot of calculating repetitions is if you can set it up in a table, you let the table take care of itself. You're just working on it. And let's be candid with each other. If we all had Excel and could just build a spreadsheet to do this, you probably put in 3 calculations and numbers will all spit themselves out. But understanding how the formulas in the spreadsheet work is the whole, you got to know how your sheet works. Okay, so that's why you guys are finishing up. Let's take a look at what this little table we set up is going to help us do. So if we start at the center line, what's this saying? Well, we know our road is 8 foot wide, both edge of pavement. So if we said that the width between the center line and the edge of pavement is 8 feet, that's where that 8 feet came from. So to get from the edge of pavement to the top of the curb, we said the curb is 1.5 feet wide, right? So edge of pavement, top of curb, we've got that length. From top of curb to the sidewalk, how far is it? Well, let's just check our math right now. So it's telling us that we have 14.5 feet from the center line to the face of the walk. So what do we have? We've got 14.5 feet. Well, we have 8 foot of this, 8 foot of pavement, 1.5 feet of curb. So what's this distance? It's 14.5. You guys seen it? 14.5, and we're going to take away 8, and we're going to take away 1.5. So it's 5 feet, right? So from the width from the back of the curb to the face of the walk is 5 feet. And then what did they say? They said that the sidewalk is a 5 foot walk, so we got that width there. So we now have all of the lengths across the cross section to be able to run our calcs. Everybody see it?
Mm-hmm.
Any questions on how any of those came to be? All right, so let's go. Let's add another line. Let's look at our slopes between them. So we know center line to edge of pavement is 3% slope, so we can go ahead and add that 3% there. What else do we know? Well, we know between the edge of pavement, the top of the curb, we know that's going to move up, right? That's 6 inches. We got 6 inches of delta to get to there. Let's just go ahead and I'm just going to put 6 inches up, just so we don't forget. So to get from top of curb to the edge of the sidewalk, it's 5 foot wide at 1%. And then our sidewalk is 5 foot wide at 2%. So right now what we've done is we built a little calc kind of crib sheet right there. What's the length and what's the slope? So what's our delta between the two? So that delta is just what? Simply the change of the height that we're going to have in between those points. So like we already pre-calced, 8 feet at 3%, it's going to be 0.24. Now you see a minus sign there, right? Go ahead and throw that minus sign in, because we're going down. We want to make sure that we remember from center line to edge of pavement, we're dropping by 0.24. So we're going to subtract. Am I going too fast? Everybody okay? Making sense? How about edge of pavement to top of curb? Well, we said we're going 6 inches up, so we're going to go plus 0.5 feet. How about top of curb to edge of sidewalk? 5 feet at 1%. Right? We're going to raise up, let me just double check the math, 5 feet at